Number 1 from 1.2, example number 1. What we're going to talk about, and before I do example number 1, it says define a function. So I'm gonna say what it wants us to do is that it asks the question, is y equals x squared a function? Alright, so in order to answer that question, what do we need to know? What do we need to know? We need to know what a function is. So here's what we do in algebra a lot, okay? What we normally have is some sort of mathematical relationship where we have x equals some input value. And then normally what that does is that goes through some sort of mathematical manipulation, right? And so that's what I'm going to call it, is a mathematical manipulation. Okay? You know, like we'll take the number and we'll multiply it by 4 and add 2 and divide the whole thing by 10. But we'll do some sort of math here. And when we're done with the math, what happens is it spits out a value. And normally we call that y value the output. Okay? Now we've got a lot of titles for the input versus the output and all that stuff. Another title that we use for the input is domain. And what's the corresponding output term? Range. Now, a function is a special type of mathematical relationship. In mathematics, as we get higher and higher up in mathematics, we tend to be a little more formal. Because we use a lot of proofs in calculus, and which makes sense, and I don't want to go through like the last 500 years of mathematics history, but I mean, the reason that math works is because we follow certain rules and logic and we prove things, and as long as we stick to those rules, the answers are valid. So in math, it's really more than just adding, multiplying, subtracting, and dividing. It's about equivalent statements and proofs and showing and proving that this number is equal to that number. And well, we're in the pre-calculus stage. So for those of you going on to calculus, we need to be a little more formal. And so what this looks like then is that I have all my possible x values, okay? And then I have all my possible y values based on this mathematical relationship, and we call this the range, all right? And we call this the domain. Now the only two restrictions on the domain, there's only two, and that is we cannot take the square root of a negative number, and we cannot have 0 as a denominator in a ratio. So arbitrarily, I could choose anything based on this, because there's no square root, right? And there's no fraction. So x could be anything, right? So I'm not gonna write numbers down. I'm gonna represent the different x's by x sub 1, x sub 2, and x sub 3. Does that make sense? Now here's the thing. If I were to plug certain numbers in, I would get corresponding y values. So if I were to let one of the x's equal 2, one of the x's equal negative 2, and one of the x's equal 1, when I plug that into the equation, which I'll call f of x, right? So if I have a function, and I'll just go ahead and say it, yes, this is a function, right? I'm going to say that because I want you to see why it's a function. So it is a function, so as I go through my function f, I get corresponding y values. Well, if I plug in 2 for x squared, in other words, instead of thinking this as x squared, think of it as something that I plug in squared. So if I take this 2 and put it up here, what will I get? 4. So now if I take this negative 2 and I plug it in there, what will I get? 4. So this one goes to 4. This one also goes to 4. And if I plug in this one, what will I get? 1. Okay? So this is an example of a function because how many arrows are leaving the x's? Well, there's one unique mapping from this x value. Does that make sense? From this x value, I only draw or map one time to the range. Now it is true this y equals 4 has 2 arrows coming towards it, but we really are not concerned about that. When we define what a function is, we're going to focus on the domain. So if you were to draw a mapping of f, the domain will only have 1 arrow or mapping leaving from it. In fact, the formal definition will say 1 unique. Right? So that's a function. Now watch this. If I take and change this around a bit, and I say y squared equals x. And I do the same thing. But now I'm going to let, in my domain, I'm going to slide this up here. But now in my domain, what I'm going to do is I'm going to let x equal 4 and x equal 9. And when I map this, what will be my answer? Well, what I need to think of is if this equals 4, what is y squared? It'd be the square root. So y could equal 2, and what else could y equal? Negative 2. So here, when I do this, how many arrows are leaving x equals 4? 2. Not a function. It's a mathematical relationship. It's an equivalent statement. When y equals 2, 2 squared does in fact equal 4, and there is a mathematical relationship between the two. But it is not a function. Does that make sense? Likewise, what would be the two mappings from x equals 9? Y equals 3 and y equals negative 3. So again, I have more than one mapping going through that. There's lots of ways you could look at this information. Another way that you could look at this information is consider the graphs of the functions. In this function here, what the graph would look like is like this. This is y equals x squared. But now if we consider the second function, or no, I shouldn't say function, the second mathematical relationship, if you were able to graph that, it would look like that. So we have a test that basically does the same thing, checks the same thing for this, and it's called the what test? The vertical line test. And what the vertical line test is that if I draw a vertical line, it only intersects one time on a function. there's only one intersection. So by dropping a vertical line through the function at any point on the function, across the domain of the function, if it only intersects one time, then we could say that it is a function. However, this is a true mathematical relationship, but if I drop a vertical line through it, it intersects more than once. Which this and this is saying the same thing, sort of. And so, since it intersects more than once, we have to say not a function. It's a mathematical relationship, but it is not a function. Does that make sense? Now, there's one last way to look at this, and that is with a table of values. So now if I come back to my function and I write the table of values, I said that x was equal to 2, negative 2, and 1, and then my y values were 4, 4, and 1. Notice that in your table of values there are no repeating x's. There's only one 2. There's only one negative 2, and there's only one 1. Again, that only occurs when it's a function. However, if I were to do that with this mathematical relationship, I have 4 corresponds to 2. I have 4 corresponds to negative 2. I have 9 corresponds to 3, and then I have 9 corresponds to negative 3. We have repeating x's, so not a function. Now some of these things you could do on your calculator, like the graph. Some of these things you have to calculate by hand because your calculator is designed and made for functions. We can graph this, but not in a function mode. We have to go into a different mode that allows us to graph that. Or we have to split it up into 2 functions. Are there any questions?